Let's talk about graphics for communicating thermal indoor climate. Designing a building is often a collaborative process involving different types of experts. One of the experts is the simulation expert, who estimate performance of the thermal indoor climate and present the results to the rest of the design team. Sometimes the design teams understand the simulation results, and that's great, but sometimes they don't. This may lead to wrong design decisions. And then the users finally move in, they start complaining about the thermal comfort. So, how can we create graphical presentation of thermal simulation results which are understandable to non-experts in thermal climate, and thereby motivate and empower the design team to engage in the thermal aspect of the design? To find out, we invited different building experts to a workshop session, discussion improvements on visualizations of thermal indoor climate. This included architects, clients, constructors, and engineers. Some participants found temperature to be quite abstract, asking what temperatures are acceptable. Discussions gave rise to the idea that clothing level would be an understandable measure of thermal comfort. For instance, if you need to be in underwear at office, then the office is obviously too warm. But how can we illustrate the amount of occupation time different clothing levels are needed to stay thermal neutral? Graphics should be recognizable. As example, dividing bar chart was not interpreted as recognizable. Dividing a cake, on the other hand, is quite common. A graphic should, however, also look nice and appealing in order to catch the attention and trigger the curiosity. The final results then became a speedometer-like graphic common known from car driving. So, this is our final graphic, illustrating the percentage of occupation time different levels of clothing are needed to stay thermal neutral, as in predicted mean vote equals to 0. This graphic shows how the users would prefer sitting in underwear at office doing 19% of working hours a year. Hopefully, a design team would immediately agree that this thermal indoor climate is not acceptable and then do something about it. We mean, if you need to be in underwear at office, then the office is obviously too warm. The reason behind all these hours in underwear can be found in a histogram of the operative temperatures during occupation hours. Here we see a noticeable amount of hours at temperature which a simulation expert would identify as overheating. Comparing design alternatives during design decision is often needed, and this is also possible in these graphics as well. In this design alternative, the thermal indoor climate become more acceptable. Looking at the histogram of operative temperature, we notice a difference in overheating hours. From this graphic, the design team would hopefully choose to proceed with second design alternative. But what if the client loves the first design? Then we need to inform the design team with relevant knowledge on the thermal aspects of the designs. How to do this? Overheating is caused by heat loads, such as solar load, lighting load, people, and equipment load. To illustrate the heat loads, we choose a histogram. A histogram is common known from math in elementary school. Illustrating histograms of heat loads together, we notice how user and equipment loads are the dominant loads in this case. We could also compare design alternatives in the histogram. Let's look at the two office designs from before. The biggest difference between these two designs are solar load caused by the different glazing areas. We could improve the design with higher solar heat by improving the solar shading system. We could, however, also try to decrease the dominating heat load, the user and equipment load, demanding lower user density in the office room. The heat load caused by light is very little in both designs. Improving lighting system or daylight availability would not affect the thermal comfort remarkable in these cases and could be neglected in further design development. So, what graphics should a simulation expert bring to a design meeting? This is our final suggestion. Thank you for listening.